So what do these objects all have in common? Well, we have here a visualizer, a microscope, a camera, a spectrometer, a pair of binoculars, fancy pair of glasses, and of course a telescope. Well, the answer is, of course, they all work with lenses. All of these have lenses somewhere within their construction. And in this section, we're going to see how lenses work. These are what a lens looks like. These are all convex lenses. And what I mean by convex is that they're slightly fatter in the middle than they are towards the edge. It's a lens like this that would be in my glasses and in most of the apparatus that I just showed you. A convex lens works by refracting the light that goes through it to a focus. Now what I have over here is an apparatus which demonstrates that exact thing. And I'm going to shine some light from this laser through a convex lens. This does not look exactly the same as, well, one of these. It's a completely different shape. What you need to appreciate about this is that it is basically a slice of lens. You can see they have the same, hard to show you this, but they have the same cross section. And so if this was a real lens, it would be circular in this axis, but we don't need all of that. We just need a slice of it to demonstrate how the light refracts through it. So I'm going to make this environment darker, and then I'm going to show you what goes on inside a lens. Righto. We're going to now draw a ray diagram through this convex lens. And hopefully by doing so we'll understand a little bit about what a lens does to light. So the first thing I'm going to do is plug in my laser, and you can see it going across the paper there, and I've got several beams so that it's really clear what's going on. And I will just turn it off a second, because the very first thing I want to do is I want to orientate my paper. So the very first thing I'm going to do is I'm going to draw a line right through the middle of my paper, like this. This line is known as the principal axis. It is just a line through the middle. Now the principal axis is like a normal line, and I'm going to place my lens on it. Now I'm trying to get it central. There's no easy way of doing it, but again I draw around the lens just in case I accidentally knock it later. And then what I'm going to do is I'm going to allow the laser beams to go in, and we'll see what happens. There we go. Isn't that incredible? Now I've just got to line it up slightly better than that. What's happening with my battery? Come on. There we go. So what is... There we are. So what is going on with these laser beams? Well, first of all, the laser beam that is following down the principal axis carries straight on through and continues straight along the principal axis. Nothing has happened to it. But now look at this laser beam here, which hits this glass at a slight curvature. So can you see the surface is not square on, the laser beam is hitting it at an angle. Now when light hits a boundary at an angle, it causes refraction. And you can see that it is curved. If the normal would be perhaps about there, it's curved towards the normal, and then it has emerged this side. And in curving towards the normal, it has changed the direction of the light until the light is passing over here. So what I'm going to do is I'm going to mark on with an X the light going in and the light coming out. And I'm going to do that to all of my rays. So that I can then draw on with that one's going down the axis, just like this. And I'm going to have an excellent ray diagram afterwards. So to draw the ray diagram, I turn off the laser, I remove the lamp, and now I can draw. So I'm going to connect these lines, and I take them just as far as the surface of the lens for now. Obviously I can't draw the one that goes down the principal axis because it just can't. And then I draw that one, and then I draw that one. And you can see I'm getting a very nice ray diagram. Now, the key thing is ray diagrams always should be drawn with pencil and ruler. It's just a thing. Now, what about what's happening inside the lens itself? Well, we can just connect the two. So where it's going in and where it's coming out, that's perfectly okay. Just like this. Just like that. We also put an arrow on just to indicate the direction of those rays. Now, what is very interesting is that all of the rays of light on this top half of the lens have been steered down towards the principal axis, where they cross over the principal axis and carry on the opposite side. These ones at the bottom have been steered upwards towards the principal axis, and they all meet at this point here, known as the principal focus, or just the focus for short. Now, this is the ray diagram for a convex lens. There is a different type of lens, and I'll get one of those out and show you that. Now, there is a second type of lens. This is called a concave lens. If I was to show you it, it's probably not really that obvious, but if you look at how wide it is at the top, and then if I squeeze it in the middle, my fingers are almost touching, it is thinner in the middle than it is around the edge. It is concave, like a cave. Now, I have got a slice through of this, and it's only concave on one side, but it should still enable us to draw a ray diagram. So the first thing I'm going to draw is a principal axis. In the previous section of this video, I spelt the word principal wrong. It's principal axis. And I'm going to place my concave lens on it like this. Now I wonder, will it bring the light to a focus? Will there be a principal focus? Would you like to make a prediction about what's going to happen? Well, this is what happens. Oh. Now, the first thing to note here is that two of these light rays are actually missing the lens. So what we'll try to do is just ignore those two light rays, and we'll concentrate on the three that we can see. So let's line it up on the principal axis, and we put some little X's to mark on what is going on. But what you can see straight away is that this lens is causing, due to refraction, the divergence of the rays that come out. They are no longer crossing and forming a focus. They are in fact being sent in all directions away from the principal axis. So again, turn off my laser, I remove my lens, and I draw on those rays to the surface of the glass, and again to the surface of the glass. Let me join these two up here. And then again, we've got to join these two. Arrows to point the direction that they go. This is a concave lens.